Okay, polygons plus circles. A polygon is a two-dimensional shape with several straight sides and angles. It needs to have three or more. Think about it. Why does it need to have three? Just think about it. It needs to have three or more. And a circle, if you don't know what that is, you should Google it. Okay, question number one. In the square ABCD, side AX, or length AX, is equal to XD, so this is the midpoint from AD, X is in the middle, and they equal 5. What is the area of triangle XCB? XCB. Okay, so take a step back, and before you jump into the Pythagorean theorem or, get all stressed out about it, we should just kind of see that if this is the midpoint, this triangle is going to take up half of the square. The triangle is going to take up half of the square. So all we have to do is find the total area of the square and divide by 2. Well, if that's 5 and that's 5, the side length is going to be 10. 10 squared is 100. 100 divided by 2 is 50. It's that simple. Boom, we're good. Question 2, the trapezoid ABCD, so ABCD, it's a trapezoid, and the rectangle ABNM are pictured below. AB is equal to 2x. AM is equal to x. DM equals NC, so DM equals NC, they both equal 5. What is the area of trapezoid ABCD? Okay, so the formula for area of a trapezoid, if you will recall, is the average of the two lengths, right? The average of the two lengths times the height. So we would have 2x plus 2x plus 10 divided by 2, right? Because we want to get the average of the two lengths. So it's this plus this. 5 and 5 is 10, and we're going to divide by 2 to get the average, and we're going to multiply that whole thing by x. That will give us the area. And you can also think about it as taking this little guy, bringing it over there, and making a rectangle. So the rectangle would have both of these sides would be the same, and they'd both be 2x plus 5. And this guy here would be x, because you take this triangle and move it over there. Press pause if you don't get it. All right, so if we have that, either way we do it, we're going to get the same answer. It's going to be x times 2x plus 5, which is 2x squared plus 5x. So 2x squared plus 5x is our answer. If you do it over here, it's the same thing. You get x times 4x plus 10 over 2. You divide both of those terms by 2 and you get x times 2x plus 5, which does kind of look pretty familiar to this down there. And our answer is going to be A. We're good to go. Question 3. In the square ABCD, AD equals 3 times the square root of 2. What is the area of the square? Okay, so it's pretty simple, because it's just 3 times the square root of 2. Times 3 times the square root of 2. Now if we remember the commutative property, we can just remember that if you have A, B, C, D all multiplied together, which you could think of this as A, B, C, D, you can multiply it AC times BD and you're going to get the same answer, right? So you can flip around the order of multiplication, you're still going to get to the same place. So we can rewrite this as 3 times the square root of 2 times the square root of 2. 3 times 3 is easy, it's 9. Square root of 2 times the square root of 2 is also easy, it's 2. Think about it for a second if you don't get it. Press pause if you need to. Come back, 9 times 2, well if you need a calculator you're probably in trouble. Obviously the answer is 18, we're good to go. Question 4, in the square ABCD, AD equals 3 times the square root of 2. So AD equals 3 times the square root of 2. Well, that's just the same as question 3. How fun. It's very similar. Let's read on to see what we're doing here. What is the perimeter? That's how I changed it up. It's the perimeter now, not the area of the square. So all the side lengths of a square are the same. All the side lengths of a square are the same. We got to add all these up together. And if I told you what is 3x plus 3x plus 3x plus 3x. I bet each and every one of you would say 12x. Now I'm telling you now, 3 times the square root of 2 plus 3 times the square root of 2 plus 3 times the square root of 2 plus 3 times the square root of 2 follows the same principle. You can think of just square root of 2 as x if you want, or just think of it as the same term, because you know it is the same term. It is not that scary. Square roots are not scary. 3, 6, 9, 12, 12 square root of 2. You add them all up together, you get 12 square root of 2. We're good. Question 5. In the square ABCD, we're getting used to ABCD. AD is equal to 3 times the square root of 3. Okay, that's a little different. What is the area of all the shaded squares below combined? Okay, so there's one way to do this, which is where you really stress out and you try to find the area of one of the squares, and then you multiply it by 1, 2, 3, 4, 5. Yeah, you could do that. I guess that's, that's a legitimate way to do it. Here's how I would tackle this problem. Just like question 1, we took the area of the entire square and then we divided it by 2 to get the triangle. Oh, remember question 1, memories. That was fun. Okay, here we can get the area of the entire square and times it by 5/9, right? Because we have 1, 2, 3, 4, 5, 6, 7, 8, 9 equal subsquares. So if we take the big area of the whole square and multiply it by 5/9, then we will have the area of all the shaded parts. It'll be awesome. It'll be amazing. Work with me. We're going to do this. Okay, so what is the area of a square? It is, length times width, or this squared. So 3 times square root of 3 times 3 times the square root of 3 is like 3 times 3 times the square root of 3 times the square root of 3, which is like 3 times 3 times 3, or 27. Don't fight it. 3 times 3 is 9. Square root of 3 times square root of 3 is 3. 3 times 3 times 3 is 27. Okay, so the big guy is 27. Now we're going to multiply that by 5/9. So you can think of 27 as 27 over 1. And you do this multiplication problem out, and if you got a calculator, which you don't, you just plug it in, 5 times 27 divided by 9. But one of the skills that we have to get better at, just so we don't use all our energy and all our concentration and all our stamina on long form computations, is we should see right away that 27 divided by 9, 27 can be divided by 9. So we can say this and this turns into 3 over 1, right? And you get 15 over 1, which equals 15. Right? Because you get 27 over 1 times 5 over 9 equals, you can think of it as 27 times 5 over 9 times 1, right? Because of the commutative property. And then this reduces to 3. 3 times 5 is 15. That's our answer. We're good to go. Question 6. In the square below ABCD, AD equals 3 times the square root of 3. All right, more of these. What is the perimeter of one of the shaded squares below? Okay, so if we have 3 times the square root of 3 is one side length, then each of these, which is a third, is going to be 3 times the square root of 3 divided by 3, which equals just the square root of 3. So this guy is the square root of 3, this guy is the square root of 3, and this guy is the square root of 3. Remember I said before, I compared this to adding the variable x. So if you think the square root of 3 is x, x plus x plus x is obviously 3x. Square root of 3 plus the square root of 3 plus the square root of 3 is equally as obviously 3 times the square root of 3. Okay, so if you have your nice little square there, and you know that this is the square root of 3, and you're looking for the perimeter of it, this is going to be the square root of 3, this is going to be the square root of 3, this is going to be the square root of 3. Square root of 3 plus the square root of 3 plus the square root of 3 plus the square root of 3 is 4 square root of 3. Don't fight it. It's the answer. We're good to go. Question 7. In the circle below, the radius is x minus 20. That's a weird radius, but don't, it's not that weird. It's just a number, x minus 20. And the circumference is 60 pi. What is the value of x? Well, we all know that circumference equals pi times diameter, right? Yeah, we all know that. And if you know the circumference equals 60 pi, then that's going to equal pi times diameter. And if we divide both sides by pi, we know that 60 is going to equal your diameter. And if 60 is going to equal your diameter, you know the radius is half the diameter. So what we're going to need to do is we're going to have 2 times the radius to equal 60, right? It's pretty straightforward stuff. Your radius is x minus 20. So 2 times x minus 20 will equal 60. And some of you are just like, I'm ready to guess and check. Well, yeah, that's cool. You can guess and check. I mean, this might be in the grid-in questions where you can't guess and check, but if you're ready to guess and check and you just want to get the answer, that's fine. The way I would do this is I'd divide each side by 2. Those cancel out. 60 divided by 2 is 30. 30 equals x minus 20. Add 20 to each side. X will equal 50. And we're good. On to question 8, in the circle below, the radius is x minus 20. That's familiar. And the area is 100 pi. That's a good area. What is the value of x? Well, we all know the area of a circle equals pi r squared. Here, we're told the area of the circle is 100 pi, so that's going to equal pi r squared. Divide each side by pi. 100 will equal r squared, right? Okay, that's fun. Why don't we just take the square root of both sides? You know, see r squared, we want to solve for r, so, you know, take a square root of both sides. R will equal 10. All right, what's my r? My r is x minus 20. 10 has to equal x minus 20. I'm just going to do the inverse operation thing. 30 equals x. We're good. Now question 9, ABC is an equilateral triangle with a perimeter of 15. Well, if the perimeter of an equilateral triangle is 15, then 3x must equal 15. Divide each side by 3, and you get x equals 5. So you should just know this intuitively. 5, 5, 5. You should be told that if you have an equilateral triangle with a perimeter of 15, your brain should just be like, bam, each side has to be 5. Each side has to be 5. Okay, what is the circumference of the circle with center A? So A to B is 5. We know that because boom, 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 15, boom, 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 5, 5, 5. Okay, so the radius is 5. We're looking for the circumference. Circumference equals pi times diameter. Diameter is 2r, so we can write that as pi times 2r. My radius is 5, so circumference will equal pi 2 times 5. Circumference will equal 10 pi. We're good to go. And finally, question 10. In the figure below, all angles are 90 degrees. AB equals BC equals CD, and EF equals FG equals HE. Okay, so all these little short guys are the same. And AC equals DE, and these big guys are the same. Well, that's pretty cool. How many rectangles are similar to CDEH? So CDEH, not including CDEH. Okay, so let's do this. Just think about these, you know, think about this 1, 1, 1, this will be 2, this will be 1, 1, you know, this will be 2. So we're looking for things that are similar to 1 by 2. Remember, similar means has the same proportion. So if it's 1 by 2, it could also be 2 by 4, right? 1 by 2 is similar to 2 by 4. Well, how many 1 by 2s do we have? Well, not one there, not one there. Oh, we have one here. Here's 1. So 1. We can't count this one because we already have it. And here's a 1 by 2, so that's 2. And here's a 1 by 2, so that's 3. Okay, cool. Any more? We have 1, 2, 3. All right, how many 2 by 4s do we have? Well, here's a 2 by 4, right? No, it's all the way down because it's 1, 2 by 2, 1, 2. Yeah, there's one. So we have one of those. All right, do I feel good about this? Anything else? Let me double check. Yeah, I feel good about this. The answer is 4. 1, 2, 3, 4. We're good.